I just want to point out that number two, this is meant to be a was meant to be a synthetic division problem, but that x squared plus two made it a long division problem, which will not be on your test. So it'll just be synthetic division. Okay, so you just um, find that factor and then go through synthetic division for number two. So sorry about that. Got to let you guys know that there was a change to that problem. Okay. Did you guys all pick up the additional handout today? So this additional handout just has some specific problems or types of problems that I want us to be able to do. It especially has the trig integrals, depth integrals involving unit circle value, as well as even and odd functions. And so let's go to, the additional handout that you picked up. Yeah, let's go through the first page. Let's just see how well we can do this. So this is number one here. Number one says find the average value. So this requires average value theorem. I'll work through it at the same time you guys do. Okay. Oh, by the way, let me just make sure we're clear on our calendar here. So our test is going to be on Friday. Tomorrow, I do need to start the calculator portion of your test, which will be next Thursday. And it'll just be 3 FRQs. So tomorrow we'll get a taste of what those 3 FRQs can look like. It'll be a particle motion, a derivative graph, and Riemann sums, table of values. But we can still spend a little bit of time to review it tomorrow. But Friday is your non-calculator test. And then Monday, we can continue reviewing for your FRQ test, which will be, again, 3 FRQs. Tuesday and Wednesday, I do need to start the next unit, but we can use the second half of the class to continue reviewing. And then next Thursday, this will also be worth the test grade. It'll just be 3 response questions. So that's our plan. So this unit is going to have 2 test beds. Okay, average value field. So average value theorem is really just depth integral with a bit of coefficient in front. Right? Really, that's really So average value, again, is kind of like finding average height. So we know that this graph, this function is going to experience an average height of 3 if we're to compare all the compare all the heights among over the course of this interval. And now we just want to figure out where is the graph actually going to hit that average height. So we basically are just looking for the order pair. We have the y value. We can just go back and find the x value. Now with average value theorem, it's possible to hit that average value at the endpoint or in between. So mean value theorem for derivatives, we're forced to have to find a c value that lives between. But for average value theorem, it's okay to have your c value be at the endpoint as well as in between. So 0 is okay, and 2 is obviously between. Number 2, average value theorem, but we're dealing with trig. Again, non-calculator, so we have to get all the way down to the ratio values. We can't leave our answer with trig left in our for our average value. Okay, so unit circle values, tangent of pi over 4 is 1. Tangent of negative pi over 4, think of that as 7 pi over 4, which is going to be a negative 1. Pi over 4 plus pi over 4 is 2 pi over 4. If I flip that, that's really 4 over 2 pi. We get 8 over 2 pi, which is the same thing as 4 over pi. That's our average value. Okay, number 3 and 4, we're practicing second theorem. We have a function that has a definite integral in it, but we're asking for the derivative of that definite integral. So that's application of second theorem. 8. Number 4, both my upper and lower bound are variables, so I have to repeat that process I did with the upper bound with the lower bound. I'm not worried too much about the cleanup, so any variation of your answer is fine. Any questions with second theorem? Okay, let's move into even and odd functions. Okay, so even and odd functions, we're starting off with even function. We have 2 properties here. We always want to graph the shorter interval first. That allows us to kind of build out our graph. Now, as soon as you graph your shorter interval, not your smaller area, your shorter interval, that's our priority. Then apply the even and odd property for that shorter interval. So go ahead and fill out what's going to happen on the other side. Are you going to create a mirror image if it's an even function, or are you creating equal but opposite because it's an odd function? After that is set, now you can fill in the gaps of that larger interval. A lot of times that larger interval is going to be an overlap, and we have to make sure that the overlap indicates there's a portion that's already complete, and we want to fill in the gap that's not complete to make that larger interval statement true. So between these two, which has the shorter interval? 0 to 3. Okay, so we know we're going to start with this one, but there's an issue with this integral that we need to adjust. What's the issue?
It goes from 2 to 0.
Yeah, so right now this is going backwards. So this is not really a -4. This is really a +4. So to help us see that, we always, if we're trying to read the graph, we always prefer to read from left to right. Otherwise, the number is going to be opposite of what we expect. So this is what we want to graph. We want to graph a region above the x-axis now that we're reading from left to right. Part A is even. I put my shorter interval in place. I'm going to fill my other side with the even property as well. Now we can fill in the gap. From -3 to 6, it must equal to 10. So this whole region needs to add up to be 10. We don't want to do this. We don't want to put something over the 4s here, because if we're putting something over that, then we're changing the overall value of the integral. But we know that this portion is complete. We should have to figure out what is the remaining gap that we can fill in. So this is 8. That 8 is accounted for. So what's left remaining? 2, right? Because we know that the total region will add up to be 10. So if this is 2, then what can we say about the other side? Also 2. Now we can total the region that they're asking for from -6 to 3. Which is 10. Part B, odd function. Start with your shorter interval. 0 to 3 is 4. It's an odd function, so we want the other side to be opposite. Larger interval. We know that from -3 to 6, it's going to total to be 10. This is already taken care of here. So what's remaining? 10. And if this is 10, then what's going to be on the other side? -10, because it's odd function. Yeah. Now we just have to add up what we see from 0 to 6. 14. Okay, do we need to see any more even odd functions, or do we feel comfortable enough with this for Friday's test? Okay. All right. Okay, let's try 7 through 10 here. So 7 is use substitution. But it's a little bit of trial and error, because you're looking at that going, wait, what's the U value? And whatever we pick for the U value, we're trying to make it match one of the rules that's available to us. We know the derivative of secant is secant tangent, so therefore the antiderivative of secant u tangent u, it must be secant u plus c. So that allows us to see, well, maybe it looks like the parentheses can be our u values. And then this derivative should handle this because even though that x doesn't feel like it can produce x squared, this is in the denominator. So if I make that 3x to -1, my derivative will produce something that is squared because I'm subtracting 1 from that -1. So I want to replace the 3 over x and I also want to replace the dx in terms of u and du. Number 8, expansion doesn't quite work. We have to rely on u substitution, but there's some additional steps required because after we make our substitution, we're not going to be able to get that x to cancel out on its own. So maybe change a variable will help us get past that point. The X is unresolved. We have to find a way to get that X to be taken care of before we can apply power rule. So we got to make another set of substitution. The X gets replaced in terms of U. Continue distributing through until all the parentheses are gone. Then we should be able to rely on just power rule to get to our answer. Don't forget your U value is only a temporary variable. We want to bring back our original variable here. Oops, I forgot about the 5 here. Number 9, there's only one term below. We should rely on just expansion, separating, splitting up into individual fractions and handle them independently. No U substitution here. Okay, number 10 is use substitution because we don't have a rule that can handle tangent squared, secant squared. So if you think about your options here, your parentheses can either give you your u value being tangent or your u value being secant. If your u value is secant, the derivative will be secant tangent, and secant tangent is not going to quite fit as nicely as if the u value was tangent. So okay, we should be able to handle the antiderivative using power rule, but make sure you bring back your original variable. Hey, this is not far enough. We cannot have trig in our final answer. Same thing on the AP exam. We have to get it all the way down to the ratio value. So a power over 3 or order pair is 1/2 root 3 over 2. So tangent is sine over cosine, root 3 over 1. It's root 3. Tangent of 0 is just 0. So now if you want to leave your answer unsimplified, that's fine. This is okay, but we got to get it past this point. So this is fine. Or if you want to clean it up even further, you can get it all the way down to root. Oh, I'm sorry, I messed up here. This is u squared. U squared becomes u cubed. I incremented it by too much. For next 5 minutes or so, can we continue with the next page? It says morning review at the top here. Know how to raise it to there. So sine to the 3/2. That 9 cube seems difficult, but it'll say take the square root first. What's the square root of 9 cube? And 3 cube makes a lot of that. We'll make the number smaller, but we're gonna make it larger. Okay, so your homework is you can finish these 2 pages. So I didn't put a page number on it, but just that morning review session worksheet that you're on, front and back. So problems numbers 1 through 9. So I'll check that tomorrow. I encourage you guys to start looking at your derivative and integral rules. We've gone through pretty much all of them. So page 16 on your test review has an organized list of derivatives and integral rules. And then page 59 to 61 from your unit packet, I have blank copies where you can practice recalling those rules. So it'd be good if we start that tonight. That way you have today and tomorrow to kind of get ready for your test. Okay. There's one thing I didn't quite get to review, and that is with completing the square arc trig. So we'll do that tomorrow after we get through our review for our first day of review for our calculator portion. Okay. All right, come to your phones.
I'm asking a question like this one, where you go from equal to.
Yeah, I haven't gone over this rule yet, so I'm not going to put that on.
Okay.
Yeah, so this is one of the newer rules, which I'll.
Okay.
It won't be on.
So like, what's the test that we did teach as a calculator?
You mean when it's just there's not there's a couple of derivative and integral features that I haven't gone through yet. So there's just like 2 or 3.
Okay, so it's a new thing.
Yeah, it's a new thing, but a couple of files.
Okay. Yeah.
Okay, great. Thank you. Do you have the, this drink card? Oh, yeah, yes. Phil, I'm not gonna put these national law rules on.
Okay, thank you.
Yeah, go ahead.
Honestly, I'm kind of panicking because I'm thinking that I did that one. I think I was It's a board.
But yeah. Got home, so like yesterday. Back. Yeah. You try to take the train to Florida. They go like and we wait there for like an hour and we never take. Yeah. She's like, wait, there's like this lunch and it's on the cup. Everything is here. I forgot what you get out. This.